Hi everyone. We're going to talk through this question here because I think it's pretty indicative of what an application question looks like for quadratics that are in Vertex form. This one comes right out of your textbook. It's question 12, I think, on page 186, and it reads that the path of a soccer ball is modeled by the equation below, where d is the horizontal distance in meters after it was kicked, and h is the height in meters above the ground. So we have these two variables, d and h. It asks us first to sketch the path of the ball. What is the maximum height? What is the horizontal distance at the maximum height? What is the height at the horizontal distance of 20 meters? And where else is the height also the same as in D? So this kind of question I'm showing you because I think it's fairly consistent that once you can wrap your head around a question like this, you can apply it broadly to any of these application questions. So let's just work our way through it. But the kind of things that you're seeing that they're asking here about maximum height and maximum distance, those are very common things that you'll see asked about in questions of this form. Okay, so let's take a look at the first one to sketch the path of the ball. So I've drawn out a grid here and I've just scaled it a little bit. It's not beautiful, but it's enough to give us a point of reference. Now, first of all, we recognize a couple of things. First of all, this is in vertex form, so I recognize that this parabola of y equals x squared has been shifted to the right by 28 and has been shifted up by 49. I also noticed that this parabola is going to be opening downwards since it has a negative value for a. So to start with, let's just plot that point. We know that vertex is going to be at 2849, and this isn't perfect, but let's just see if I can get it roughly close. 2849 is probably in around there, roughly speaking, so sort of 28 and 49. Make it a bit bigger. And for our purposes, it's simple enough to assume that because this is tracking the path of a ball, that the initial object was kicked here at 0, 0, that it had no height and no distance. I also know that this is the axis of symmetry. This should be symmetrical across this line here, so I'm just going to sort of sketch that out so I can see it visually. And that's going to allow me to sort of roughly sketch in here a parabola, which should, if the halfway mark is 28 and that's just past 50, so somewhere over here, let's go like that. Okay, so it's not beautiful, but we get the idea. Up, and the ball comes back down. Okay, something like that. Okay. Okay, so now we can start to answer questions about it. First of all, some things that should be obvious. The maximum height here is the maximum height the ball reaches. So as the horizontal distance passes, this ball is rising up higher and higher and higher and higher, reaches the maximum height, and then it begins to come back down. So we could, just by roughly looking at this image, determine right away how far the ball went. Okay, so it should be that distance right there, which in our case is going to be 2 times 28, since we know the halfway mark was here at 28. I'm not sure, I don't think the question actually asks us to find the total distance traveled, but that is a common thing that is asked about, and so that might be something you want to pay attention to. We should also be able to see here that it has a maximum height of 49, because that is determined right from the vertex. So let's move on here. Sketch. Now, these are the things that it asked about. It said, what was the maximum height? So already, just from the equation alone, we can tell that the maximum height had to be 49. The question says so we can check that off. What is the horizontal distance at the maximum height? So once again, from the vertex, we knew that its horizontal distance was 28 meters to the right at the time when it was reaching its maximum height. So we can check that off. The next thing it says is, what is the height at a horizontal distance of 20 meters? Well, you could guess that from the graph. So you could go back to the graph and using a horizontal distance of 20 meters, approximate it. But we have an equation, so we shouldn't have to actually do that. We can in fact solve it. So let's try that over here. Let's put in our values. H is equal to negative 1 over 16. Multiplied by, now we have, it's saying what is the height as a horizontal distance of 20 meters? So the horizontal distance was 20 meters. So subtract 28 squared plus 49. So that tells us negative 1 over 16. 20 minus 28 is negative 8 squared plus 49. Negative 1 over 16. Negative 8 squared is 64. So let's actually just write it as 64. Okay, plus 49. I'm just going to move on. So we'll just continue this work onto our next slide. So we had negative 16, 1 over 16 times 64 plus 49. So this is going to be negative 4 plus 49. This is going to be 45 meters. Okay, so what that's essentially telling us is that at a horizontal distance of 20 meters, the ball was 45 meters high. And this should even make sense just thinking about that graph that we had here where we had the parabola, because we know we had our maximum height at 28. So when the question asked what is the height at 20 meters, well, that's slightly less than, right? So we should be less than the 45 meter max. So the idea that we've come up with 45 meters at a height of 20, or sorry, at a horizontal distance of 20, sort of makes sense. Okay, so now the last question here, let's just jump over to the next slide. So the last question here says, where else in the height is, so where else is the height the same as in part D? In other words, where else is the height 45? So there's really two ways to do this. One is to think about it from a symmetry standpoint. So if we went back to this graph here, we know we have our maximum here is going to be at 28, that this at 20 it was 45. So we could say here that the distance from here to here, since this whole parabola is symmetrical, is 8 meters, and so that if we went another 8 meters on the other side, that would also give us the same thing, which really puts us roughly here at 36. And so that would be true. From a symmetrical standpoint, we'd be at the same height, 45 meters, if we went the same distance over. However, we could also solve it mathematically. So let's just clear this away. And go back and say, given this equation here, we're going to substitute in for h and this time solve for d. So in this case, let's just make this a little bit wider. So now h is going to be 45 meters, and that's going to be equal to negative 1/16 d minus 28 squared plus 49. I'm going to bring the 49 to the other side, makes it negative, so we have 45 subtract 49, and that's going to give us negative 4. And we'll just take this onto our next slide. So now we're going to have negative 4 times 16, because we're going to move that d minus 28 squared, and that's going to give us negative 64. Really, we're just undoing the same values we did in the last one. So then obviously negative over here and negative over here, we can just make that into a positive. And so if now we wanted to solve this, 64 is equal to d minus 28. So if I want to get rid of this squared, I'm going to square root both sides. And here is where the trick comes in, because typically you're going to look at this and say the square root of 64 is 8, which is true, although it's only partially true, because in actual fact the square root of 64 is plus or minus 8, right? That is to say, positive 8 squared will give us 64, and negative 8 squared will give us 64. So the truest answer to the square root of 64 is plus or minus 8, and that's got to be equal to d minus 28. So now what we find is that if we take this over here and bring it to the other side, let me just include on a new slide. So now we have plus or minus 8 plus 28 equals to d. So remember, we're trying to solve for where did the height equal to 45. And the first value, okay, so if I was to do, let's do negative 8 plus 28, that's going to give us the one that we'd already seen before, right? Negative 8 plus 28 is 20. So we knew that at a horizontal distance of 20 meters, then we would get a height of 45. But it's this other value here that we hadn't looked at before, which is positive 8 plus 28 is equal to 36. So just like we saw in our symmetry, there's actually 2 points in the parabola that give us a height of 45 meters, and that was at the point 20 meters and at the point 36 meters. So we looked at it symmetrically, but we also calculated it algebraically. And the reason that we got 2 answers out of the algebra was the fact that when we took the square root of 64, that we had 2 possible answers, positive 8 and negative 8, and that's how we ended up with our 2 values. So hopefully that question is a little bit helpful to look at as a way of analyzing these types of problems.